So, back in 1994, a physicist named Miguel Alcubierre published a paper that, well, it pretty much blew everyone's minds. He laid out a mathematically solid way to travel faster than light that doesn't actually break the laws of physics as we know them. He called it the warp drive, and it's all about bending the rules. Let's dig into his original idea. All right, so if we're going to talk about how to travel faster than light, we've got to start with the one big rule that says you can't. And this isn't just a guideline. It's one of the most basic, fundamental laws of our universe.
I mean, this is the big one, right? The question that fuels basically all of science fiction. We've always been told that hopping over to another star in a human lifetime is just a fantasy. But is it really? Is that the final answer?
And here's where it gets really interesting. Einstein's theory is super precise about this. It says nothing can travel locally faster than the speed of light. And that one little word, locally, well, that turns out to be everything.
You see, that word isn't a wall, it's a loophole, a really clever one. It's the key that Alcubierre realized was a brilliant way to get around the cosmic speed limit without ever actually breaking it.
Okay, think of it like this. You can't be a faster car on the highway. That's breaking the speed limit. Impossible. But what if you could just move the highway itself? That's the trick. The spaceship isn't breaking the speed limit in its little patch of space. The whole patch of space is what's moving at this incredible speed, carrying the ship with it.
Honestly, the best way to get your head around this is to picture yourself as a surfer. You're not trying to swim faster than the wave. No way. You're just riding the wave. Alcubierre's idea is to create a wave in the very fabric of space-time and then just surf it to the stars.
Okay, so space-time surfing. It sounds cool, but how would it actually work? Well, Alcubierre's paper gets right into the nitty-gritty, and it's all about a cosmic push and pull. It's basically a two-step move. Behind your ship, you get space to expand, like really expand, which pushes you forward. And at the exact same time, in front of the ship, you make space contract, pulling you along. It's this amazing push-me-pull-you system using the universe itself.
And that's the absolute key. It's not your engines doing any of the heavy lifting. As Alcubierre put it, space-time itself becomes your engine, propelling you on this wave you've created.
And here it is. This is the visualization straight from his paper. This is the warp bubble. The ship just chills out in that flat, calm region right in the middle. That big peak behind it, that's space-time expanding. And that deep valley in front, that's space-time contracting, pulling you forward. Now, this is where it goes from amazing to, like, completely unbelievable. For anyone inside this bubble, the ride would be perfect. You'd feel zero acceleration, no getting crushed into your seat. And get this, no time dilation. Time would pass totally normally for you. You could pop over to a distant star and back, and you'd have aged the same as everyone back on Earth. It's incredible.
Yeah, it all sounds a little too good to be true, doesn't it? A smooth, paradox-free ride across the galaxy and, well, you guessed it. There is one absolutely massive, physics-defying catch.
So what is it? What's the secret ingredient we need to actually build this thing? What's the huge hurdle standing between us and the stars? The answer all comes down to something called exotic matter. Yep. To pull off this incredible trick of expanding and contracting space-time on demand, you need a substance with a property that just sounds made up: negative energy. The math in the paper is crystal clear on this. To create that warp bubble, you need negative energy density. And that violates what's known as the energy conditions in classical physics, which basically say that energy should always be a positive number. You can't just have less than zero energy. So, is that it? Is that the nail in the coffin? Does this impossible requirement just kick the whole idea firmly back into the realm of science fiction? You'd think so, but amazingly, no. Even Alcubierre himself, right in the conclusion of his own paper, didn't see this as a complete deal-breaker. He acknowledged the huge problem for sure, but he also pointed toward a little glimmer of hope. And that hope comes from the super weird world of quantum mechanics. See, while our big-scale everyday physics says negative energy is a no-go, quantum field theory actually predicts that tiny, fleeting pockets of it can and do exist. There's a real, observed phenomenon called the Casimir effect that proves it. It's a tiny sliver of hope, but it's there. So that leaves us with this tantalizing thought. The math works. The loophole exists. The only thing missing is this stuff, this exotic matter.
that our deepest understanding of quantum physics suggests might not be impossible after all. So the question is no longer just if we can do it, but what we would do with that kind of power. If we figured it out, where would humanity go first?